Hey, welcome to .NET Diagnostic Tooling with AI here at .NET Conf. I'm going to be showing off some new things we've added to tools like .NET Trace. So hopefully these things will be useful for your apps and your projects. Um, my name is Jonathan Peppers, and I'm a principal software engineer. I work on .NET MAUI. I also, work on Android related things, things related to performance, so that type of thing. So yeah, it's been fun, working on this team. So some of the things we're going to talk about, I'm going to give an overview of the different diagnostic tools you can use in .NET. Um, I'm gonna give, some of my opinions, other opinions about AI. I have AI in the title of this, talk, but, um, it's worth just going through that a little bit. I'm gonna demo a slow app, so it's gonna be a .NET MAUI application that I made slow on purpose. Um, and then I'm gonna show, like, how you can trace that app, and then I'll use AI to make the app faster is kinda the idea. And then the second demo, I'm gonna do the same thing with an app that has a memory leak. Um, and we'll also use AI to fix the memory leak. So then we'll just kind of recap about everything that we talked about. So let's talk about .NET diagnostic tools. Um, of course, if you're just getting started into profiling or performance or looking at your app, I think that just using Visual Studio on Windows may be actually the easiest way to get started. You may have noticed that when you just F5 your application, like this like diagnostic window pops up. You can also go into debug windows, show diagnostic tools to find it. But it has some tabs in there that are basically equivalent to some of the command line tools I'll be talking about. So there's a tab on CPU usage. It's the picture on the bottom right that's basically the same as .NET Trace. And then there's a tab on memory usage, which you can take snapshots of all the objects in your app, all the .NET objects, and see trees and things, and that's equivalent to .NET GC dump. All right, so this is the best way to get started, especially if your app runs on Windows. I would try this out first to get an idea about profiling performance. Now, the .NET Global tools, these are nice because they work, on non-Windows, so, like, you can run these on your Mac or on Linux, um, and these are the tools that basically do the same thing as Visual Studio can do, at the command line. So, .NET Trace, um, is a tool that can record CPU usage or other events, like, you can even declare your own events and log them in here, and it saves, its information in a nettrace file or a speedscope file. Now, nettrace files are kind of meant to be opened in Visual Studio, or a tool called PerfView that I'll talk about. Um, and Speedscope files, you can open them at a website. It's a little web app that just kind of opens the file locally. But Speedscope.app is a website that you can use on Mac or Linux for looking at traces, right? So we're checking out those things. Um, so .NET GC Dump is a tool that will attach to your application and just take a memory snapshot. And the file it saves is a GC dump file. Um, and right now, the best option is to open it in Visual Studio. Um, I have written a little command line tool that lets you open them on Mac, but really Visual Studio is the best option. You kind of need a visual editor for this. And then lastly, .NET DS Router, that is the tool that makes all these things work on mobile. So it is you might think of it as some kind of proxy, but it like forwards the connection to a mobile device, like or an emulator or a simulator. So it can connect to your .NET MAUI application. Um, so you use DS Router together with the other tools, and I'll demo how that works because we've made it easier in .NET 10. So lastly, I mentioned Purview. Perf view is like it has so many buttons. It's like, I mean, this is like looking at something out of Star Trek, right? Like, if you're already into performance profiling and you want to look at stuff on Windows, like this can do everything. So it can do things like look at the whole operating system and everything that's happening and how many and multiple processes. And so if you're really wanting to dig deep, it's worth taking a look at Perfview. I always like to mention it, but um, for this talk, I'm going to kind of focus on the .NET Global tools in Visual Studio. So, okay, so let's talk about AI. So, I know a lot of folks out there, are maybe lukewarm on AI, or maybe they don't like AI. So I'll just give some of the opinions that I've heard that I kind of agree with. Um, and I just want to be realistic here. So here's a quote from Scott Hanselman. We want AI to be more like Iron Man and less like Ultron. I want a co-pilot that's going to have a conversation with me. So yeah, that's kind of what I agree with. Like AI yet is not a replacement for people at all, really. Maybe kinda, but it's more of a productivity tool for people, right? So I especially like AI, like when I'm in a place when I literally have no idea what I'm doing, like I'm working on a new code base, or I don't know where to start. Maybe I have writer's block, right? Um, Chatting with Copilot in your IDE is a way to really just get started on what you need to do, right? Like, um, example is I'm working in a repo and I don't know what file to open to make the change. Like a lot of times Copilot can like find the file for me, and that's already an easy win. And I think of it as a productivity tool more than anything, right? Um, so yeah. So when it comes to AI and performance, um, a lot of the times AI is gonna find the obvious glaring issue, um, that would be easy to find if you went and looked yourself, right? And so in that regard, I feel like if AI finds a performance issue in your app, it's the one you should go fix. It's probably the worst one, right? Like, it's the obvious one. Um, and, AI gets things wrong too, so, it could sometimes suggest things that aren't really a problem, but that's why we have humans reviewing their work, right? So, uh, all right, let's talk about some demos, right? Um, so first thing, disclaimer: the demos I'm doing are using AI. Hopefully, they all work. If they don't, I have an example of the files I need and things like that. So, but we'll see what happens. First, we're gonna look at a slow app. Um, and I could have demoed this on several platforms. I'm just gonna do it on Android, because I feel like it's gonna, let me show off DS Router and how things work and how things can connect together. Um, and this app is slow on purpose as well. So, so let me stop the PowerPoint slide. All right, all right. So what this app is basically a Maui template, and there's a button that you click, and it does something that's slow and takes a while. And so let's go ahead and run the app. Um, so yeah, you've probably seen this type of look. Um, but if we this is pretty much the default template in .NET 10. But if we click process data, it takes a few seconds, completed in 2,700 milliseconds, whatever. Process 10 million items. So this is slow in debug mode, probably much slower than you'd see in release mode, because we have the IDE attached. We're also on Android, we're using the interpreter, so hot reload works. Um, so I'll show this in release mode, but it'll automatically be a little faster in release mode. But let's also attach a trace to it, right? So I'm going to stop the app, and I'm going to go to just a terminal. Um, And so to trace this app, uh, basically you would run .NET Trace collect, DS router Android. And we've recently simplified this command. Previously, you would have had to open a second terminal and run DS router yourself. And instead of all that, mess to do that, we've just kind of done it into one command now. And so things will start up. Um, right now, it's waiting to attach, and it kind of prints some examples of like, here's how you need to build your app in order for it to connect up to .NET Trace, right? And so the two options are default and startup tracing, and we're going to do default. Um, and the only difference is it has diagnostic suspend false. And what this does is the app will pause on launch and wait for it to connect to .NET Trace. And that's useful if you're wanting to profile startup, which we're not really looking to do that. We're wanting to profile a button click. Um, so I'm going to just stop .NET Trace and run this command. Uh, I may need to add. No, I think this command will work as is. We'll try it. This is building release mode, so it should just take a few moments. We'll see. Um, but the idea, so the reason you build the app this way is it will automatically include a diagnostic component in the app, which normally in release mode you wouldn't want to be on the App Store. Uh, okay, so this is now running in release mode, nothing attached. Um, and let's just see how much faster it is. Or yeah, so it's about 450, about 500 milliseconds, and that's just running release mode. What what you would expect to see. So let's actually attach .NET Trace. And then what I'm going to do is I'm going to hit enter, wait for it to look like it's going to be connected, and then I'm going to click the button a couple times. So I'm just going to make sure. Okay, it looks like it's working. I'm going to click the button 3 times and then hit enter. All right. So that dropped a .NET Trace file in the current directory, and I'm going to just open this in Visual Studio. We can get an idea of what's going on here. Take just a moment to open. Yeah. So you'll notice here there's already a lot of information that Visual Studio can just show you by default opening a NetTrace file. It finds things like hot paths, um, which are very likely things that are slow. So I know that that button, it runs some system link. And so these things are probably right on track as to what is slow in this app, right? Um, it's making a 10 million item list and running link expressions on them. So yeah, that's going to be slow. Um, so the part this is useful in its own right to just be able to get this information about your app, and you can click on the different methods and decide yourself what you wanted to improve. But now we have this generate with Copilot button, and this is the new thing that I wanted to show off here. So it basically opens Copilot chat and says, "Can you suggest some optimizations?" Right? And it's going to tell me some things um, that I could go do myself. But instead of doing that, let's actually just say, like, uh, "You make the changes for me, bro." Right? Uh, and let's just see how it does. Right? So it has all of that background of what it saw in the trace and what it thought we should do, and now it's just gonna go and change our code, and let's just see what it comes up with. This could be time saving, but maybe you know exactly what to do, right? Um, so let's look at some of the changes. Um, so we can see some of these are. It's also building the app. Cool. We'll get back to that, but you can see that some of the things it came up with are absolutely relevant. So there's a list of T used here, and it's just setting the capacity on the list. Otherwise, these add commands will need to resize the underlying array as you add, and it has to copy the array when it does that. So, like, doing this is an obvious win, right? Like, it did the exact right thing. The next thing I see it did is instead of just using a plain string and plus equal, it actually used string builder and called append. And then I'm sure it uses, it does to string on the string builder at an appropriate time later. Um, Another thing it does is it kind of estimates a capacity for the string builder. I think that's probably useful if it's a 10 million item list. Yeah, I think that totally makes sense. Now, here we get down to the link expressions. Um, and what was interesting here is that it was calculating evens and odds, right? And so one thing it did that's pretty smart, instead of doing all these expressions, um, it has a list for evens and a list for odds with a capacity that it knows are going to be half of the number of items, right? So all these changes are good. Um, and actually, these two link expressions right here may actually not even need to be called, and so it removed them completely. Like, I don't think this function actually needs them. So let's go. Let's run our app in release mode again. So previously it was taking about, let's just say, about 500 milliseconds. So let's just run the app again and see how fast it's going to be now. I'm hopeful that will be significantly faster. And we didn't actually write any code. We just told Copilot to fix our code, right? So, and just in case, I'm going to take a screenshot real quick of this so we can compare. Uh, that's really big. Uh, so if we click process data, it is significantly faster. So it went from 535 milliseconds to 133. We got the same answer. The hash is different. We might want to look into what changed there. But um, we do have significantly improved code. That is interesting. Why did the hash change? Uh, I bet there could have been a trailing comma before. I bet that's what it is. It's something to do with the trailing comma. We had a trailing comma before, and then Copilot fixed the trailing comma. Okay. But that's why we need unit tests, right? So, but you could see where, like, this workflow could be extremely useful in profiling your apps. It's, worth trying. Yeah. So let's go to the next demo. So this one I did just completely in Visual Studio Insiders. But the next one I'm going to actually do in VS Code. And let's just open here. Okay. And um, either of these, you could have used whatever IDE you want, except for when I'm specifically was using some Visual Studio features. But this VS Code one, I think, is also fun. Um, so this is an app where I have a leaky page. And the reason it's leaky, um, it's subscribing to the property changed event on a window, and it never unsubscribes, right? And so when you do an event subscription like this in C sharp, the subscriber has a reference, or sorry, the event publisher has a reference to the subscriber, because it needs to be able to call the method on the subscriber, right? And so the window, especially on Android, the window is the life of the entire application. So the window never goes away, and you may have more than one leaky page as you navigate through your app. Um, and so these leaky pages would just kind of leak forever. Like, every time you navigate to a page, you're just going to have a leaky page. Let me, before I run this app, just close a few apps. Um, so let's go. I'm going to run the exact same command just to um, make sure we're doing the same thing. So this is an app with one button, and we'll click. we'll go forward to the leaky page and then we'll go back. Um, and we'll do that a few times to just make several leaky pages hanging out forever. One other thing to mention when testing this is um, when I'm debugging a memory leak, for temporary debugging purposes, I usually add a few GC collect calls to the application. And the reason you do this is so that um, objects that are about to be collected by the garbage collector have a chance to go away, and that will reduce your confusion when you look at a memory dump, right? You don't want uh, things that aren't leaking to show up in the memory snapshot, right? So our app is probably launched now. So I'm just going to click. This is the leaky page. It's completely blank. That's fine. I'm going to go forward. I don't know, like let's just do like 3 times. Um, and then we can just run dotnet gc dump collect ds router android, right? And this should connect up to our running app and it drops a file in the current directory, just like what happened before, right? So so we'll open that file. I'm just going to open that file in Visual Studio, which is really the best way to view this file. And this is a kind of a snapshot of every .NET managed C# object in the entire application, right? If we search for leaky page, we can find, yep, there's 3 instances of leaky page. Um, and so a really nice feature of Visual Studio is it has a path to root menu here. And the hot paths only will show you what it thinks is keeping this thing alive. Now, it's kind of doing a rough guess, but most of the time I find that this is absolutely correct and exactly what I was looking for. So, um, but we can see here the leaky page. Oh, it's held on to by a property changed event handler, right? Hmm. And then, which is on a window, right? Exactly the bug we created. And that window is held open in a list that's in an app.current backing field. So that makes sense. So .NET MAUI apps have an application class. Application.current holds the app. The app holds a list of windows, and the window holds the page. And that's the thing that leaks forever, right? So here's how. So to diagnose this with I had to write a little code to do this. And so what I've made is, well, so the general problem is any of these Copilot menus or LLMs, they can't open binary files. So if you ask Copilot, open this GC dump file and tell me what's wrong, it can't open it, right? And it'll probably just lie to you or whatever and not know what the problem is, right? And so what I've written is an MCP server that you can say, look at this GC dump file and um, it will return text information that the LLM can read. Um, Basically, the same thing that's happening on my screen right here. I have an MCP server that can do the same thing, right? So let's look how that works. So here's my MCP server, and I'm just going to click to start it, and hopefully this goes well. Let me get the right page open as well. Okay, so if I say um, I have another copy of the dump file that I'm probably going to have it open instead, but I have one in my data folder because the one that I opened has a date in the name, and I was afraid I would type that wrong. But so I could say open data slash memory app.gc dump and fix the memory leak in my application. And let's just see what happens. So hopefully it calls my MCP server. Um, it's already calling it, I can tell. So I have a few different functions that it has access to. So analyze top by inclusive size. It just kind of gives it a table of just like when we were looking at Visual Studio, the table at the top of all the things. It's like you were sorting by inclusive size, right? Um, and then it analyze top by counts, another method it can do. And then finally, it decides that, hey, that maybe there's a problem with this leaky page, right? And so it's searching the leaky page, um, searching property changed, and then it comes up with the problem itself. And it's already suggested the fix for the memory leak, which is unsubscribe from the event, right? So if we subscribe in on navigated to, we need to unsubscribe from on navigated from. And so this would fix the memory leak. And what's nice about this is that, right, it went and fixed the problem for me. And I know if you gave it a more complicated leak, maybe it would not be able to completely fix the code just like this, but maybe it could give you some suggestions on what to investigate next, right? So let's do a recap. So the two demos, I showed .NET Trace and opening a NetTrace file, and this is what you'd use to diagnose a slow application. And then you could use the Copilot button in Visual Studio to investigate further. Um, and the .NET GC dump is the tool I use to diagnose a memory leak, and I used an MCP server to let Copilot investigate. Now, that server that I made is just a prototype that I made, but we're looking into making that thing a real product that everyone can use. But so just be on the lookout when that thing exists. Um, we're hoping that all .NET developers can use it when it's ready. So. And so recap on, how I feel about AI is like, I really like AI when I'm not the expert on what I'm trying to do. I think of it as a tool to me, and I think of it as productivity tool, right? As far as using AI to do investigations, right? Especially performance investigations, if it finds a problem, it probably is like a really obvious problem, and that's probably the one I need to go fix. Uh, that's why I like using it to do initial investigations, right? Um, and so last part of this, everything I showed here today, we really focused on making DS Router easier to use. Um, and if you have tried it in the past and had trouble, I would try it again with our latest release. You may just have a lot easier time. Hopefully, it'll be as easy as what I just showed on these demos. So, um, yeah, and if you haven't ever profiled any of your applications at all, I think it's worth doing it just to see if there's some easy wins in your applications. So yeah, lastly, try out .NET 10. Um, we hope you like it. There's a lot of things in .NET 10. So thank you.